Hello, students. Looking at 11.3 homework. So if you notice, I've given a chunk of homework problems here, skipping a couple. Obviously, I didn't like number 1, 13, didn't like 11, 23, or 25, but um, let's take a look at some of these. So question 1, again, this one I just thought, I felt like it's getting a little too nuanced. There's nothing wrong with the idea of two planes intersecting, but now we're talking about three-dimensional. How are you describing that to someone? So I'm just going to leave that one off. That's obviously not going to be something I'm going to test on. Your goal is to find the measure of the angle marked X. So as you start doing these problems, I think you'll start getting into a kind of a good rhythm. If you happen to see a right angle, remember that is 90 degrees. And the total for a triangle has to be 180. So again, 65 plus 90 plus who knows what gets you 180. Use a tiny bit of algebra. You can find the missing piece. Here they give you a little bit less, it looks like, but they're still giving you a lot of information. Remember, the sum of these angles has to be 180. But also this angle right here is supplementary. So I don't know what this object is, question mark, but I know that question mark plus 2x has to equal 180 degrees. So really my question mark is now 180 degrees minus 2x. So take that and put it right in. Use these pieces. So if you don't know something, it's okay to label. It's okay to write all over it and just say right there is 180 minus 2x. Then you take that number plus x plus 60, and it has to total 180 just like before. Okay. Let's see here. Find the measure of a complementary angle, a supplementary, and a vertical angle. This is practice using the new things, the new terms that we've decided on. Complementary adds to 90. Supplementary, straight line, adds to 180. Number 4 ties in what we're doing. Excuse me. It ties in what we're doing with some terminology linked back to chapter 8 with algebra. So 15 more than 4 times the measure of its complementary angle. Well, I don't know, but let's call its complementary angle x, right? So if I have two angles, x and y, so an angle y, right, measured more than its complementary angle. So what do I know? Right off the bat, if it's a complementary angle, I know it equals, when I add them together, I get 90. And I also know that this angle measures 15 degrees more than 4 times the measure of its complementary angle. And guess what I have? I have two equations, and I can go through and solve it through substitution or elimination. Again, your choice. This is, I'll put degrees on there. This is completely up to you, but it does link back to chapter 8. And you can kind of see why we pushed chapter 8 prior to getting into this. Oh, let's move down. What's the measure of a supplement? Of the complement of a 20-degree angle. So that one's, you got to get through the wording. It does say supplement, but supplement of what? Oh, it's of the complement of a 20-degree angle. So it's like a function of a function. Just pause, do the first piece, then come back and do the second piece. So don't try to do it all at once. I think it makes it more complicated. And here's your chance to use degrees, minutes, and seconds one more time. If the measure is this, what's the measure of the supplement? We get some algebra. These are measures of the supplementary angles. And then down here, we get into some more with, what is this? Oh, the parallel lines cut by a transversal. So if we do those, then it says prove. Now notice in part A, prove the lines are parallel. Okay. So they're going to tell you that these two angles add up to 180 degrees right inside here. If you know they add up to 180 degrees, can you prove to me that the lines are parallel? This goes back to the theorem about alternate interior, alternate exterior, or complementary, because right now that's the only way that we can prove things are parallel. We have a theorem about that. Then it says in B and C, solve for X. So again, now in B and C, we're told the lines are parallel. So I know the lines are parallel. Now it's time for me to kind of use that as we go forward. Okay. Okay. Yeah, these are kind of cool. I mean, honestly, they're kind of cool little pictures. But yeah, if you were totally getting stuck here, maybe, huge hint, it doesn't look like there's much going on here, right? But just remember, one of the things you get to do when you're in charge is build things if you don't like the way it looks. So what do I mean by that? You are in charge, so you could say, I really wish that it was just the way that the book had it, where it was just parallel lines like this. Okay, so draw a line like that, and you can say it's parallel. You can say, okay, this line is parallel. So K, we know K is parallel to L, and here's now line M. Cool. So I'm going to say now M is parallel to L, which means if it's parallel, then this 30-degree angle comes right up here. I know those are corresponding alternate interior angles, actually alternate interior angles. Right, so I know this part right here is 30 degrees. And then go up top and say, well, wait a minute. What about K? K is parallel to M. So this angle here would be alternate interior to this angle. So you might have a way of doing this where you don't have to do too much. That's one approach. You could also say, wait a minute, Scott, can I just do this, Scott? Can I just draw this angle up here? And I'd say, yeah, just extend a line. And then you would know this angle is alternate interior with that one, right? So this one becomes 30. And now you've got a triangle. And maybe it's easier to solve with a triangle. So yeah, heck yes, draw something else. If what you see there isn't really working for you, draw something else. All right. Let's see here. What else did I say homework was? Through 10 and then skip 11. Okay. Guess I did. I got to skip 1, 2, 3, 4, 5, 6. I'm skipping this one. Find the sums of the measured of the measures. Yeah, I personally didn't like that one, but yeah. Find the measure of each of the interior angles of a regular dodecagon, a 12-sided. So once again, once you find, you'll have that formula. It tells you how many sides there are, and you can say, based on what we have, what's the sum of the interior angles of that? Let's see here. Determine the measure of an angle whose measure is 2/3 of its complement. Okay. Once again, think of it. What's its complement? Has to add to 90. So I create an equation. And then the angle is 2/3 of that. Got it. So I now have two equations and two unknowns. Let's see here. 12. Calculate the measure of each angle of a pentagon where the measure of the angles form an arithmetic sequence. Yes. But just as a hint, it does give you something here, right? It's a pentagon. So you know that you start with 60 and then you create a arithmetic sequence. You're going to have 5 total terms, and then you want to add them up to get that total number of angles. So use that piece and you should be able to find that common difference. Once you have the difference, you can find all of the angles. Not that anything's wrong with this question. I think I was just like, I didn't particularly necessarily like the wording of it, but it's fine. I mean, if you wanted to do another problem, you could do that one. Let's see here. Very similar. So here I have angle Y. There's 2 of them right here, and they are congruent. And it says Y is equal to 3x. So I could write that in, just put 3x in there. And then remember, they are supplementary with the angle right over here. And then the total triangle in there adds up to 180. So it is about connecting. Once again, here's another one with an arithmetic sequence. It tells you V is 136 degrees. And you can kind of take a look and see how it looks like it's like smallest looks like it's over here, a little bit bigger, a little bit bigger, a little bit bigger, kind of going it around. That's what it kind of looks like to me. Which other one I skip? I said 14 through 22. So here we go. Again, they'll tell you 50 degrees. Right down here, they'll tell you 90s in a couple places. I think that's helpful. You should be able to use what you know about triangles. One thing that I'll tell you that, again, some students in the past have said, hey, I really struggle with some of these, Scott. Is there a way you can kind of help show me? Sure. What I would do if I were you is I would just come over here and redraw it if you need to. And if you're like, but that line in the middle kind of gets me because I think there's something else going on. Well, don't put the line in the middle then. Just you come over here and do this and say 50 degrees here. Could you find the missing angle, which is right there? Now, once you build that one, go ahead and write it in, and then you can kind of ignore this part and then focus on this other little triangle. And maybe you could then find how much there is on top. Once you have that, you can kind of work your way around to any of the other pieces. Right? There we go. Look at this. We got a nice little octagon and we extend the sides. So you are most likely going to have to deal with exterior angles. There are 2 of them here and they are congruent because it says it's a regular octagon. Then we got a home base or a home plate. Home plate actually has 3 right angles, but the other 2 are definitely not right angles. So your goal is to find how much it is and just understand that the sum is kind of your key. How would I do this with the sum of these angles? All right. Find the measure of x. So again, 2 right angles and then 4 that are congruent. This is a quadrilateral. Opposite angles have the same measure. Question is, what kind of quadrilateral is it? If these opposite angles have the same measure, what can you say about this this quadrilateral? Is it a parallelogram? Is it a rectangle? What do I know about it? And when it says justify your answer, that's like saying, can you prove that? Can you guarantee that it should be okay? Let's see here. And we have one other. So we know 4 angles. We're missing one of them. And we're actually trying to find the exterior angle to that missing one. So again, from the picture, we should be able to do that. Look at this, a little zig, a little zag. I love that. And it does say that AX is parallel to DY. So AX would be this bottom line here, and it is parallel to DY. So I know those are parallel. I see some other lines coming in here. And this is where, to me, colored pencils or, I mean, even crayons would probably be just fine. Because when you have other lines coming in like this line right here, and this line right here, I mean, you kind of ask yourself, wait a minute, are those lines parallel? And you can see there's a transversal that cuts them. And then you can see 40 degrees here and 40 degrees right there. Is that enough? Forgetting the rest of the picture, is that enough for me to know those 2 lines are parallel? Let's see here, 22. Yeah, once again, prove angle 1 equals angle 4. If the measure of 2 is equal to the measure of 3, can you prove 1 is equal to 4? Okay, going to come back to some of the definitions. Not going to do 23. I think I skipped that one. And the measure of one interior angle of a regular polygon is 135. Oh, so now we're solving the other direction. Now I'm going to tell you the angle, and you have to find how many sides there are. Okay. But again, there's a calculation that tells you exactly how any triangle, any hexagon, any pentagon, how do I calculate the sum of the interior angles? And I think I skipped 25 as well, didn't I? Yeah, I skipped 25. And then here we go. Suppose an isosceles trapezoid has the sum of the interior measures of 2 consecutive angles is 36 degrees. What is the sum of the other 2 angle measures? Again, it is a trapezoid. Go back and see how many sides does it have? How many sides does it have? That'll tell you about the angle calculation. All right. That's it for homework. There you go. So a decent amount, make sure you have your calculator handy. That's going to be a big thing. Also make sure colored pencils are not bad to have, or at least different colored pens. I know some of you have like different gel pens. That's fine. Just kind of make sure it's clear to yourself. If you're using a digital tablet, when you draw things in, it's okay to kind of draw over the top and say, wait, I'm going to put red here and here so I can remind myself I'm looking at these 2 lines to see if they're parallel. I find that really helps me, and hopefully it helps you too. All right, off you go.